the model can hold the truth. Now we make it change, the right side. On paper, it's simple. A request comes in, you load an order, you change it, you save. But two things turn that simple picture into where real services break. First, you're not the only one writing. Someone else might be editing the same order at the same moment. And second, the network lies. The same request can arrive twice. A serious write path has an answer for both. Let's build one. Start with the shape of a write. A command is the caller's intent. Add this line item, submit this order. And the discipline from episode 2 carries straight over. A command carries value objects, not raw strings and ints, so by the time it exists, half its rules are already enforced by its types. The rules that span fields go into a TryCreate factory with a private constructor. So an invalid command simply can't be constructed. You get a validation error instead of a half-built request. And then the handler is deliberately boring. It loads the aggregate, calls exactly one domain method, and lets the unit of work commit on success. The handler orchestrates. It does not re-implement the rules. The invariants live in the domain, where episode 2 put them. Here's the first reality. Two users open the same order. One removes a line item. The other, a second later, adds one. Both loaded the same starting version, so the second save quietly overwrites the first, and nobody gets an error. That's the lost update, and it's everywhere read modify write happens. The fix is optimistic concurrency, and it's beautifully cheap. Every order carries a version token, an ETag, and any request that overwrites its contents has to send back the version it read in an if-match header. If that token is stale, someone else wrote in between. The server rejects it with 412, precondition failed. If the client didn't send one at all, it's 428, precondition required. No locks, no waiting. You just detect the collision at the moment of the write and make the loser retry with fresh data. The second reality is the network itself. A client sends a create order request, the server processes it, and then the response gets lost on the way back. The client sees a timeout and does the sensible thing, it retries. Now the same intent hits your server twice, and without protection you've created 2 orders, or added stock twice, or charged a card twice. The fix is an Idempotency-Key. The client attaches a unique key to the request, and the server remembers it. If the same key shows up again with the same body, the server doesn't rerun anything. It replays the original response. Same effect, exactly once, no matter how many times the network stutters. And if the same key arrives with a different body, that's a client bug, and you reject it. This is HTTP-level safety, separate from, and complementary to, the event deduplication we'll see in episode 6. Here's that write as real code. The command carries its value objects, order ID, product ID, quantity, and one more thing. The ETags the client sent in if-match. The handler is a single railway track. Load the order. If it's missing, not found. Then, right there, require a tag. It compares the version the client sent against the order's current version, stale, and the whole chain short circuits to 412, missing, and it's 428, before any change is attempted. Only if the precondition passes do we load the product and call the one domain method, add line item, which snapshots the name and price. Notice the shape, not found, then precondition, then mutate. The concurrency check is one call in the chain, not a scattered afterthought. And here's the endpoint that fronts it. Two things make it production grade, and they're almost invisible. The idempotent attribute opts this post into the idempotency middleware. A retried request with the same key replays the original result instead of adding a second line item. That's it, one attribute. Then the controller reads the if-match header, builds the command with those ETags, sends it, and on the way out, returns the order's new ETag so the client has the fresh version for its next write. The framework wires the hard parts. The middleware stores and replays, require a tag compares and rejects. The controller stays thin. You describe the guarantees. The framework enforces them on every request. So the right side is more than load, change, save. Commands are valid before the handler runs. The lost update is caught by an ETag and an if-match, 412 when it's stale, 428 when it's missing. And the double request is defused by an idempotency key that replays instead of repeats. None of that is exotic. It's HTTP, done properly, and the framework makes it a single attribute and a single call. Next episode, we turn around and read queries and why every list you return must be bounded. Subscribe, and I'll see you in episode 4.